Hey guys, Reyes here, and today we're in the 14th day of the July LeetCoding challenge, and the question for today is custom sort string. So in this question, we are given an order string and a result string, and the question is to permit the result string such that it follows some rules, and the rule is that it should follow the rule of order of precedence of characters mentioned in the order string. For example, over here in the order string, we have some precedence rule, that is like C occurs before B and then B occurs before A. So the same rule must be applied to the result string as well. So all the occurrences of C must come before all the occurrences of B, and then all the occurrences of B must come before all the occurrences of A in the result string. So this is one of the valid outputs of the result string, because C occurs before B and then B occurs before A. Since D does not occur in the order string, it does not matter wherever it comes. So that's the question. And one more constraint is that all the characters in the order string is unique, in the sense there are no duplicates of any characters. So the length is of at most 26 characters, and result string may be of at most 200 characters. So that is the question. And so one of the most brute force solution, basic most intuitive solution, is that of the brute force, where we just iterate over the order string, and for each of the characters, and suppose we are at some particular index, we print all the occurrences of that character in the result string before going to the next one. So for example, over here in the result string, we don't need the result string as such, we only need the frequency of the characters. So we can take a hash map and mark the frequencies of all characters, and then clear the resulting string so that it can be reassigned, and we can empty the resulting string. And then as we iterate through the order string, suppose we are at particular index I and there is some particular character, there's a character at that index, so we need to check if the character is there in the result string or not. If it's there, we have to print all the how many ever times the character has occurred in the result string, print assign those many assign or push back those many characters, push back those many times the same character into the result string. For example, over here we do the same thing. So I've just cleared after taking count of the frequencies of all the characters, I've cleared the string, and then just iterate through the order string. Suppose we are at a particular index I, and there is a particular character, suppose this X is the current character at the index. So if the current character is occurring in the resulting string, then iterate through the count of that character, and each time push back the same character to the string. And after that, since we have already processed the current character, make the count equal to 0. And finally, there may be some characters which occurs only in the result string and not in the order string. So for those characters, there is no precedence rule or anything like that, so we can assign it at any random position. And over here I've assigned it at the end of the string. So these are the characters which don't appear in the order string, so precedence don't matter. So this is the approach. There are so many simple approaches for this problem, and this is one of them. And the time complexity for this one is big O of m plus n, because over here, suppose order is of length m and the result string is of length n, then it's like O of m plus n, because over here the outer for loop will take O of m time for processing all the characters, and this inner for loop, the summation of all the count elements is equal to n, that is the length of the result string, and we are processing all the frequencies only once. So we are not processing it multiple times for each of the character. So ultimately we are processing frequencies only once, so hence it is O of m plus n, and the space complexity is O of 26, that is almost like constant. So that's one of the approaches, and there are more approaches. For example, there's a very short, so as the title says, it's custom sort string, right? We can just write a custom sorting function where we can just return the position according, we can just arrange the positions according to the place where we find the character. For example, over here, this one of the solutions by some other guy. So just find the position where it occurs in the string, and then if it occurs earlier in the order string, then just uh, place all the occurrences of that character before all the occurrences of the B character. So that is how we do it. But over here the time complexity would be O of m into n into log n, because this thing find function takes O of m time. So there's this O of m into n into log n, and but the space complexity would be over here negligible, and over here as well it's O of 26 only, so it doesn't make a big difference. So these were two approaches for the problem, and yeah, that's it for the video. Thanks for watching.